Hello everyone, welcome back to the GDC classes English. So dear students, as you all know, for the preparation of MRB pharmacist, we are again have the master stroke video session, and today's we are going to have question from pharmaceutical chemistry, and in this pharmaceutical chemistry we are basically going to have questions from organic chemistry. So we are going to see various nomenclature techniques, various things about organic chemistry that is actually responsible and is going to come in this examination. So let's have our first question. So first of all, we will be going to discuss what are the topics that we are going to see in this video. So we will be having questions from nomenclature of organic chemistry with particular reference to the heterocyclic. So basically we are going to have questions from heterocyclic compounds with up to 3 rings. So basically we are going to have questions from heterocyclic compounds that are 3 tricyclic rings up to tricyclic rings, heterocyclic compounds. So let's get started with our first question. Which of the following heterocyclic is a thiophene? So which will be thiophene structure? So here we are having oxygen and a 5-member ring. So this is a furane. This will be furane. Now this is what? Thiophene. Sulfur with 5-member ring. So it will be thiophene. Both are aromatic. Now here we are having pyridine. So this will be pyridine. And we are having 2 nitrogen rings fused with at 1,2 position in a single 6-member ring. So it will be, what do you call it? Like it is pyridazine. Pyridazine. So it will be pyridazine. So what have been asked in the question? It was asked about the thiophene. Which of the following is a heterocyclic compound? Thiophene. So C will be the right answer. C is actually our thiophene structure. C will be the correct answer. Furane, thiophene, both are what? 5-member heterocyclic aromatic structures. And once you also can have here like what? The pyrrole. Pyrrole is also a 5-member ring with nitrogen heteroatom. Which of the following compound is tetrahydrofurane? So which among the given structure will be tetrahydrofurane? So the name itself indicating that the structure will be having tetrahydro, that is tetrasaturated carbons. Here we are having tetrahydrofurane. So furane is a 5-member ring. Okay, so oxygen containing a 5-member cyclic ring. So here we are having what? This is pyrrolidine. This will be pyrrolidine. Okay, so saturated ring of pyrrole, it will be pyrrolidine. Here we are having a dioxane, 6-member ring with 2 oxygen atoms. So it is dioxane. It will be oxane. Okay, so oxane, dioxane, and we are having a tetrahydrofurane, that is THF. Here 4 carbons are having 1 hydrogens extra with respect to furane, since furane is having 1 hydrogens on each 4 carbons, while the tetrahydrofurane is having 1 hydrogen extra in all the 4 carbons. So it will be our THF, that is tetrahydrofurane. So D will be our right answer. Okay, tetrahydrofurane. Okay, so for the preparation of MRB pharmacist, GDC classes application is also having a free of cost test series running. That is, we are conducting tests every day at 6 p.m. So if you haven't joined till now, you must go and visit GDC classes application and enter the batch code MRB25 for this test series. And you should join this, since it's a free of cost, and you can check what is your preparation right now and how much more preparation you have to go through. So for this you have to simply go to GDC classes application at the Google Play Store. You can search it on the Google Play Store. Then simply visit batches section, enter the click on the plus symbol and enter the batch code MRB25 in small and without any spaces, and you will be joined in this course very soon. The 3-membered ring containing compound, in addition of carbon and oxygen atom, the prefix is called. So we are having a 3-membered ring. So you have to know about the heterocyclic nomenclature, that is Hans-Widman nomenclature. So basically Hans-Widman nomenclature is just like the having normal nomenclatures, but with the word roots and some other of the like prefixes. What will be the prefix used? What is the suffix used? These all kind of difference you will be having with the normal nomenclature system. So in case of Hans-Widman nomenclature, it will be having a word root, okay, word root and a suffix and prefix, just like your normal nomenclature. But in the case of Hans-Woodman nomenclature, for the cases of heterocyclic compounds, these all are some specific things. Like in case of word root, you will be going to have number of ring structure. What is the size of your ring? So word root will be going to came from ring size. Like if you are having a 3-member ring, okay, so basically the lowest size ring is 3-member. So 3-member, 4-member, 5 and 6-member. Each ring size is having a specific, you can say that word root. So 3-member will be having IR. For 4-member you have to use ET. For 5-member you have to use OL. For 6 it will be IN. For 7, okay, I am writing down here, like 7-member you have to use EP for 7-member ring. For 8-member you have to use OC. For 9 it will be EC. And okay, it will be ON, my bad. It is ON, and for 10-member it is EC. Okay, so IR, ET, OL, IN, EP, OC, ON and EC. So basically you can simply learn it by IR, IT, all in. Okay, so iritolin and ipoconic. So if you learn these two mnemonics, you simply can have the 3 to 10-member ringed word root learn by it. Like IR for 3, ET for 4, OL for 5, IN for 6, EP for 7, OC for 8, ON for 9 and EC for 10-member ring. So what have been asked in the question? The 3-membered ring containing a compound in addition to carbon and oxygen atom, the prefix is called. So it will be your word root. Like word root for 3-member will be IR and prefix. So simply prefix came from the type of heteroatom. So for each heteroatom it is having a specific name. Like for case of nitrogen it is known as aza. For the cases of nitrogen, let's suppose for the case of nitrogen it is aza. For the case of sulfur it is thia. For the case of oxygen it will be oxa. So for the case of oxygen, your first nomenclature name will be the heteroatom. So you are having a prefix came from your heteroatom, that is OXA. Oxa plus IR for 3-member ring, and this suffix came from the nature of ring. What is the nature of your ring? Is it saturated or unsaturated? So in case of saturation, it is generally used ane, and for unsaturated, it is different for each category wise. Like for saturated nitrogen also it is idene for 3, 4, 5-member ring. For the case of unsaturations it will be 4, 5, 6-member, that is ending with E, and for the rest of the cases like 5 to 3, 4, 5, okay, so from 7 to 10 onwards it will be INE. So it's a different case. So for the case of oxygen, what is your prefix? Is it aza? Aza will be for nitrogen, oxa for oxygen, thia for sulfur, selena for selenium. So oxa, that is B, will be right for oxygen atom. So B is the right case. B is the right case. Okay, B will be right. All right, moving to the next question. What is the ring size of the fully unsaturated compound without nitrogen with the suffix irene? So IR basically represents, it is for 3-member ring, correct? ENE represents for unsaturation. So for the case, it is like for unsaturated ring, you will be having ENE for 3-member ring. For 4, 5, 6-member, you will be having E, just E at the end. And for 7 to 10 onwards, 7, 8, 9, 10, it will be ended with INE for unsaturated. For unsaturation. So here we are having like without nitrogen and fully unsaturated ring, the ending is for is like IRENE, that is irene. So what will be the size of that particular ring? What is the ring size? So IR is representing like for 3-member ring you will be having IR. 3-member IR, ET4, OL5, IN6, EP, OC, ON, EC. Okay, so this is the ring size. Word root you can say. For unsaturated, if the ring is unsaturated, fully unsaturated, then you will be using the suffixes like this. And if it's saturated, then you simply have to use ane at the end. Ane, is it 3 or 10, like any one, it will be ended with ane. But there is an exceptional case for nitrogen. If a nitrogen containing ring is there and it is saturated, then you have to use IDINE. That is idene for 3-member, 4-member and 5-member ring. So ∫ will be used in case only when nitrogen is present and the ring is saturated. Even it will be having nitrogen and some other heteroatoms present too. Then also you will be using ∫ since it is nitrogen containing. So nitrogen containing heterocyclic ring, if it is present with a saturation and it is 3, 4, 5 membered, then you will be using ∫ as your suffix word. Okay, so here we are having ∫, that is for 3-member ring it will be used. For 3-member ring it will be used. Now this chart is very important. Like I have already told you that ring size, first of all we will be having ring size 3 to 10 with 𝐼𝑟 𝑒𝑡 𝑜𝑙 𝑖𝑛 𝑒𝑝 okay, so again I am talking it all in ip ok on ek. Okay, this is our ring size, and then we are having saturated or unsaturated. So if it is saturated with nitrogen, then you will be using for 3, 4, 5, like for 3, 4, 5 member. Look, for 3, 4, 5 member, if it is saturated with nitrogen, then we will be using only ∫ at the end. But if it is saturated without nitrogen, then we will be having ane at the end. Irane, etane, olane. Okay, so like this. Choose the correct option for heterocyclic compound among the following. What will be the correct option? Like bicyclic compound is indole and benzopyrene. Okay, so indole is having a benzene ring fused with like this pyrrole. So yes, it's indole. Okay, so it's bicyclic. Benzopyrene, like benzene ring fused with furane. So it will be our benzopyrene. Okay, just a moment. Furane. Like this. Okay, so it is furane, benzopyrene. Yes, they are bicyclic, like triacyclic. Phenazine and phenothiazine. So phenazine is actually having like this, phenazine. And again here we are having, so this will be our phenazine and phenothiazine. So if we have sulfur present here, so it will be phenothiazine. So phenothiazine, yes, they are triacyclic. 7-membered ring. Azepine, okay, azepine is a 7-membered ring. Azepine is a 7-membered ring. So we are having 1, 2, 3, 4, 5, 6, 7. Okay, we are having 8. Okay, let me correct it. So we will be having now 1, 2, 3, 4, 5, 6, 7. 7-member ring with epene, like unsaturation. So this is azepine. Yes, it's a 7-member ring. But what about azitidine? Az representing nitrogen atom, Et representing 4-member it. So Et representing 4-member ring, ∫ representing saturation. So it is a 4-member ring with nitrogen having saturated. So this is actually azitidine. So is it azitidine 7-membered? No, not at all. So this R will be false. So yes, P and Q are correct. P and Q are correct. So here C option will be right, like P and Q are correct. Okay, P and Q are correct. Here we are having like azitidine. It's a 4-membered ring, not 7-membered. Which is not a heterocyclic aromatic compound. So furane. Furane is a aromatic compound. Pyrrole aromatic, thiophene aromatic. But naphthalene. What is naphthalene? Naphthalene is actually a benzene, dibenzene, like 2 benzene ring fused together. So this is actually our naphthalene. This will be naphthalene. Naphthalene. So is it the naphthalene a heterocyclic structure? No, not at all. In naphthalene there is only carbon and hydrogen atom. So only carbon atom is actually participating in ring formation. So naphthalene is not a heterocyclic ring. Not at all. So yes, D will be our right answer. Rather, pyrrole, furane, thiophene, these all are aromatic structures and heterocyclic, like heteroatom containing rings. Next question we are having, out of given heterocyclic, which one is not a fused heterocyclic? Which will be not a fused heterocyclic? Like for quinoline. Quinoline is actually having a benzene ring fused with a pyridine ring. So this will be our quinoline. This is our quinoline structure. For case of acridine, acridine is also having like a benzene ring. Benzene ring is actually fused with what? Pyridine ring. Diabenzene rings are fused with pyridine ring. Phenothiazine, again we are having sulfur and sulfur and nitrogen, like a 6-membered sulfur and nitrogen rings are fused with 2 phenyl rings. Okay, so tricyclic, tricyclics. While pyridine, so pyridine is just a single ring, dear. Pyridine is just a single ring. Pyridine is not a fused ring. So yes, D will be our right answer. D will be our right answer. So acridine, that is also known as phenazine, like quinoline, like phenothiazine. Okay, all right. The name of compound given below. So what will be the name of this compound? So it is having nitrogen. So we will be starting with 𝙂𝙬. We will be starting with 𝙂𝙬. Now we are having what size of ring? 1, 2, 3, 4, 5, 6, 7. So it is having 7-member ring. So yes, we will be having azip, and it's completely unsaturated. So we will be ending with INE. So azipine. Okay, so we are having A option correct here. A is our right answer. Like quinazolinium, it's derived from quinoline. Indozolene, like it will be from indole derivative. Pyroline, it is a pyrrole derivative. So yes, azipine, it looks like a azipine. 7-member ring with unsaturations. 7-member ring with unsaturation. The pyridine is a 6-membered ring containing a compound which contain carbon and which atom? Which atom? So pyridine is actually having nitrogen atom. Okay, so pyridine is actually having carbon and a heteroatom, that is a nitrogen. Nitrogen. So A will be the right. A will be the right answer. Next question, we are having the name of compound given below. So we are having compound, like we are having a 5-member ring with having sulfur and nitrogen. So we will be having sulfur as our first atom, nitrogen second, carbon, then A, like this. So we are having, how we have write it down, that sulfur will be having the least possible number. So it's a priority sequence, that when we are having more than one heteroatom present in a particular ring, then we will be applying, like oxygen will be having the highest priority, followed by sulfur and then nitrogen. And this is only for 3 most commonly, or you can say that most primarily used heteroatoms, like oxygen, sulfur and nitrogen. So now in this cases, how we are going to name this compound? So first we will be using sulfur, like thia, then 𝙂𝙬, and then it's a 5-membered ring and it's a unsaturated, to all and E. So thiophene. So thiophene is just a 5-member ring with containing sulfur. Isothiazole and thiazole. So both are having a thiazaole. Thiazaole. So what do we mean by this iso? So iso means that is isomer. So the thiazole is actually this structure, like having sulfur and nitrogen at 1,3 positions. 1,3 positions. So if sulfur and nitrogen in a 5-member unsaturated ring, if sulfur and nitrogens are present at 1 and 3rd position, it's a thiazole. So thiazole is nothing but 1,3 thiazole. 1,3 thiazole, or sulfur is present at 1st position and nitrogen is present at 3rd position. And look, this structure is very much similar, or you can say they're similar with this. And there's difference only in the position of those particular sulfur and nitrogen atoms. So it's thiazole is actually isomer of this structure. And which type of isomer? Positional isomers. So this is nothing but isothiazole. This is actually isomer of that thiazole. So it's isothiazole. So yes, B will be right answer. B will be right answer. That is, it's isothiazole, while thiazole is basically having sulfur and nitrogen at 1 and 3rd positions. Okay, for MRB pharmacist, we are also having theory and objective books that are having compiled and complete your syllabus of that particular MRB pharmacist. What is the demand of that particular examination? So all the contents you can have it in a single book, that is MRB pharmacist examination preparation kit, theory and objective. So you simply have the content in this book and you can practice down as much questions from this book, and you must buy these books for your complete preparation of this examination. Also, you are having a pharmacist test series, online test series running, and pharmacist crash course for this Tamilnadu MRB pharmacist. So you can also check it at the GDC classes applications. What is the ring size of a fully unsaturated compound without nitrogen and suffix olane? So we are having a suffix like OL and ANE. OL is for 5-member. OL is for 5-member ring. ANE is representing the saturation. So 5-member ring with a saturation 5-member ring with a saturation. OL is for 5-member ring. Okay, OL. So it will be 5-member ring. Okay, so D will be the right answer. Since it was, let's suppose it's having nitrogen and saturated. So nitrogen containing, we are having 3, 4, 5-member. If we are having nitrogen containing 3, 4, 5-member saturated, then those endings will be idene. So it should be have olidine. Olidine. So it's not having olidine. Okay, so it is only like without nitrogen. Okay, not at all. Whether it is olidine, none, it's not the matter here. Like if it was olidine, then also it will be a 5-member ring, since it is having all, and all is basically presenting the ring size. All is used for the 5-membered ring size. Okay, all. Name of the following compound. So what will be the name? Like here we are having a 2 nitrogenous compound, 2 nitrogenous 5-member ring, 2 nitrogen 5-membered ring. So is it imidazolidine, pyrazolidine, 2H pyrazoline, or 2H imidazoline? So here we are having, if we are have these kind of structures, like we are having 1,2-diazole, 1,2-diazole, so it is like pyrazole. It's also commonly known as pyrazole. Its common name is like pyrazole. And when we are having N and N at 1,3 positions, then it is imidazole. Then it is imidazole. So now we are having 2 nitrogen at 1,2 position. So it is actually a pyrazole derivative, but the saturated one. So it will be having a pyrazolidine. Pyrazolidine. So it will be pyrazolidine. If we are having saturated version of this 1,3-diazole, then it will be having imidazolidine. Imidazolidine. And 2H pyrazoline and 2H imidazoline is representing partial unsaturation. Partial unsaturation. So if it was a partially unsaturated ring, like we are having, let's suppose this kind of, if we are having this kind of structure, like one is a pi bond present inside that ring, then it will be having a pyrazoline like structure, or you can say these kind of nomenclature will be used. So here we are having pyrazolidine. Pyrazolidine. Next question we are having, name the compound given below. So what will be the name of this compound? Like we are having pyrrole followed by second position on. So we are actually having a pyrrole 2-on. Oh sorry, pyrrolidine 2-on, since it's a saturated version. So pyrrolidine followed by 2-on. So you can simply have pyrrolidine 2-on, or you can also say that 2-pyrrolidone. 2-pyrrolidone, on representing ketone. Here also on present, but it was at 3rd position. So it is 3rd or 2nd. So 1 and 2. So it's 2nd position. So it's not correct. Pyrrolidine, no, not at all. It's saturated version. 2H pyrrole, no, not at all. It's actually having ketone group. So it will be 2-pyrrolidone. So C will be the right answer here. C will be the right answer here. Okay. Which of the following compound name is? What will be the name of this compound? Alright. So we are actually having a 3 AZA groups. 3 AZA groups present at 1, 2, 3, 4, 5. So we are actually having a 1, 3, 2 and 4. So we are actually having a 1, 2, 4 triazole. 1, 2, 4 triazole. 1, 2, 3 not at all. 1, 2, 4 triazole. Yes. That's correct. Tetrazole, no. It is having only 3 nitrogens. So triazole. It's not imidazole. Imidazole is having 1, 3 nitrogens only. So B will be the right answer. That is 1, 2, 4 triazole. 1, 2, 4 triazole is the right answer. Which, okay, what will be the correct IUPAC name for the following compound? What is the correct IUPAC name? Now oxygen, carbon, carbon, carbon. Saturated version, okay. In oxygen, so ox plus Et plus ane. Oxetane. Oxa, A will be lost it when we write A and E, we have ox, it, ane. Oxetane, where is it? Alright, A option. Okay, A option. All are 6-membered ring except, so pyridine is a 6-membered ring, alright. Piperidine is a 6-membered saturated version of pyridine. Pyrimidine is also a 6-membered ring with 2 nitrogens at 1,3 positions. Pyrrolidine, okay, pyrrolidine is a 5-membered ring. Pyrrolidine is a saturated version of pyrrole, so 5-membered ring. So these all are 6-membered, while this pyrrolidine is a 5-membered ring. 5-membered ring. So yes, D will be the right answer here. Pyridine is a 5-membered ring, while the rest are 6-membered rings. Chemical formula of pyrrole. Okay, so chemical formula, we are having nitrogen and 4 carbon atoms. 4 carbon atoms, and each carbon is having 1 hydrogens. 1 hydrogen. So we are having C4H1 extra. So 4 plus 1 5, H5 and N. So C4H5N. Look where it is. C4. Okay, wrong. C4 H4 H5. All right. So we will be having C. Okay, just a moment. Okay. C5N and C4NH. Okay, so both are correct. Look. We are actually having C4H5N. That is also correct. C4H4NH. That is also correct. Okay, so if you write it down, this is also C4H4NH and C4H4NH, or you can also see that C4H5N, C4H5N. So both B and C both are correct. Okay, both are correct. Suffix epane is generally used for. So suffix epane. So EP represents 7-member ring. Okay, so 7-membered ring. Ane is for saturation. Ane is for saturation. So basically we are having a 7-membered ring with a saturation. 7-membered ring with a saturation. 4-membered ring, not at all. 5 no. 7-membered ring with a saturated. All right. Next, okay, it could be any heteroatom present, but yes, this epane is actually representing that it is a 7-membered ring with consist of saturation only. So D is the right answer. D will be the right answer. Heteroatom is not present here. So yes, it could be nitrogen, oxygen, sulfur, any of the heteroatom. Any will be right. All right. So this is the table that we have already discussed earlier. Given structure has a following IUPAC name. So what will be the IUPAC name of this structure? All right. So this is our first position. Always numbering of these heterocyclic starts from the heteroatom. Now, the most preferred site, or you can say the most possible least number will be given to here or to here. So in case of these kind of structures, we generally give more preference to the saturated carbon. Like this is our saturated carbon with only having single bonds, while this is actually having carbon double bond. So this is unsaturated, this is saturated. So second will be given to this position, third, fourth, fifth, sixth and seventh. And at a 2 and fifth, now look, at a 2 and fifth we are actually having what? Dihydrogen. Like these all positions are having single hydrogens. Okay, all positions are having single hydrogens, but at second and at fifth, due to saturation, we are having dihydrogen. So at 2 and 5 we are having a dihydrogen. At 2 and 5, like 1 4 2 4 1 5, no, at 2 and 5 we are having a dihydro, and it is actually having ASA, that is heteroatom ASA. 7-member ring EP, ASA heteroatom EP for 7-member ring, and unsaturation for INE. So A will be our right answer. A will be our right answer. Okay, A will be our right answer. 2 and 5 is actually having 1 hydrogen extra, so dihydro. Pyrazine is the heterocycle which contains. So we actually are asked about the pyrazine structure. So we are actually having pyrazine is a dinitrogen 6-membered ring. Now there could be more, like these dinitrogen 6-membered ring. It's having like pyrazine, pyrimidine, pyridazine. If the both nitrogens are present at 1-2 position, if the nitrogens are actually present at 1-2 positions, then it will be named as pyridazine. If the both nitrogens are present at 1-3 positions, then it will be named as pyrimidine. And if we are having both nitrogens present at 1/4 position, then it will be named as pyrazine. So pyrazine is actually having 6-membered ring with 2 nitrogens at 1 and 4th position. So nitrogen has heteroatom at 1st and 4th position. Okay, so A is the right. Nitrogen has heteroatom at 1 and 2nd, 1st and 2nd, it will be pyridazine. Nitrogen has a heteroatom at 1st and 5th position. So whether it's 5th or you can say that 3rd, it's identical. Look, if it is 1, then 2, 3, 4, 5. 1, 2, 3. From this side it's at third position, from this side numbering it will be having at the fifth position. So it is also a pyrimidine derivative, and first and third is pyrimidine. So A will be the right for pyrazine, that is 1 and 4th position. 1 and 4th position. Term aziridine can be used for aziridine. So we are having Az, that is nitrogen, IR for 3-member ring, idine for saturation. So this is our aziridine structure. So it's none other than ethylenamine. Okay, so ethylenamine, it's actually a saturated version, saturated thing. So it won't be here, correct? Ethylene diamine, no, not at all. It's a single nitrogen containing, none of the above. Okay. So basically this nitrogen and this, like here we are having CH2 and this nitrogen. So this is commonly known as ethylenamine. Ethylenamine. So it will be A is correct. Aziridine is commonly known as ethylenamine. Ethylenamine. So A will be the right answer here. A will be the right answer here. Ethylenamine. Which of the following are names for cyclic ether? What will be known as cyclic ether? Like oxirane, epoxyalkane, alkene oxide, or carbinol. So this oxirane, what do you name? Oxirane. Look, this is a 3-membered ring with oxygen as a heteroatom. So cyclic ether, that is also known as oxirane. Oxirane. So yes, A will be right. A will be right. This is respect to the heterocyclic rings. This is actually, we are talking about the heterocyclic rings. Like what do you name the ethers? That is cyclic ethers. So oxirane is the right answer. Azolidine can also be termed as, so we are having azolidine. So as like nitrogen, all that is for 5-member ring. We are having idine, that is for saturated. So this saturated version of pyrrole, that is azolidine, like Az representing the aza, that is nitrogen atom. All is representing for 5-member ring. 5-membered ring. And idine is actually representing, or you can say that idine is used for the saturated ring only when nitrogen is having 3, 4, 5 member. So 3, 4, 5-member ring, we are having idine as an ending. So this none other than, or you can say that pyrrolidine. Pyrrolidine, common name of this structure is pyrrolidine. And the hands between will be azolidine. So yes, pyrrolidine, yes, correct here. Pyridine is 6-membered. Pyrimidine is 6-membered. All of these can't be answered. A is the right answer. That is, pyrrolidine is none other than saturated form of pyrrole, or you can also say that it's a azolidine. Now next question we are having 1,3-diazole is. So 1,3-diazole. 1 and 3 at diazole. So we are having nitrogen's atom present at 1 and 3 positions, and at the end we are having only E. So E represents unsaturation for 4, 5 and 6-member ends. So we are actually having this. So what do you name this ring? Is it a imidazole, pyrazole, oxthiazole, or oxdiazole? So we are not having oxygen, not having oxygen. So pyrazole and imidazole. So basically when a 1-2 position, if the diazole is of 1-2 kind, like this one. So if it was like this, like 1,2 diazole, then it will be pyrazole, and when 1,3, then it will be imidazole. A will be the right answer. A will be the right. Name the 5-membered unsaturated heterocycles containing oxygen only. So 5-membered heterocyclic unsaturated compound having oxygen only. 5-member unsaturated containing oxygen only. What do you name this ring? Oxazole. Ox, that is oxygen, aza for nitrogen. No, we are not having any nitrogen here. Pyrazole, 2 nitrogens are 1-2 position of a 5-member ring. Pyrrole, nitrogen for a 5-membered ring. No, not at all. Okay, D. That is furan. Furan. Very easy question, I guess. Very easy question. Which of these is not an aliphatic compound? Which will be not an aliphatic compound? Is it acetic acid, acetaldehyde, ethane, or tetrahydrofuran? So we have asked which is not an aliphatic compound. Acetic acid, okay. Acetaldehyde, all right. Ethane, okay. Tetrahydrofuran. So tetrahydrofuran is actually a heterocyclic. It's a cyclic compound with heteroatom. So it is not an aliphatic compound, and that is being asked in the question, not an aliphatic compound. So yes, tetrahydrofuran is actually a heterocyclic saturated compound, or you can say that heterocyclic alicyclic. Okay, which of the following is an aromatic heterocyclic compound? Aromatic and heterocyclic, like pyrrole. So pyrrole is a heterocyclic as well as aromatic. Pyrrole, furan, thiophene, pyridine, quinoline, isoquinoline, indole, these all are basically having a aromatic structures, aromatic nature. So yes, pyrrole is aromatic. You have been asked which of the following is an aromatic. Okay, so pyrrole is an aromatic, like pyrrolidine. Pyrrolidine is a saturated one, and aromaticity basically requires conjugation inside the ring. So pyrrolidine, due to absence of pi bond, can't be a conjugated one. So it won't be a right answer. Epoxyethane, not at all. It can't be a aromatic ring. Dioxane is having saturation. All the rings are saturated, and due to absence of conjugation, it won't came under the aromatic categories. So pyrrole, that is A, will be the right answer. Aromatic hydrocarbon like pyrrole, thiophene, tetrahydrophene. Oh, okay. This is not a aromatic compound. It's just heterocyclic, but tetrahydrofuran can't be a aromatic compound. Okay. The IUPAC name of the compound. Okay, it's a normal compound nomenclature. Look, just a carbon compound. So we are having carbon, 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 and methyl. So we are having one substitution present here, and chlorine present here. So we basically have 1, 2, 3, 4. So 4-member ring, that is butane. So it's having pentane, wrong. Butane, 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 all right. Now we are having both are substitutions, like methyl and chlorine, both are substitutions. So among substitutions, give priority to those that comes first. So now if we count it from here, we are having chlorine at the first position, second, third, and then fourth. So basically we are having 3 chloro and 3 methyl, 1 chloro. So 1 chloro, 3 methyl. 1 chloro, 3 methyls, 2 methyl, 2 methyl. 1 chloro, 3 methyl butane. So A is the right answer. Chlorine is present at the first carbon and methyl substitution is present at the third carbon. So yes, A will be the right answer. Which compound is named as 2-pyrroline? Which will be 2-pyrroline? Okay, so this is pyrrolidine, pyrroline, and this is also, you can say that is pyrrole structure. This is 2H pyrrole, while this is also a pyrroline. So basically pyrroline represents you can say that incomplete, or you can say the partial. Okay, we will be using better term, that partial unsaturated rings. If it's a better unsaturated saturation, like partial unsaturated rings are present, so these partially unsaturated rings of pyrrole are named as pyrroline. Now we are having like nitrogen is here. Now this that ene is present at the second position, so it will be up 2-pyrroline, while this will be 1, 2, 3. So we will be having 3-pyrroline. So this is actually 3-pyrroline, and this will be our 2-pyrroline. So it's 2-pyrroline and 3-pyrroline. This will be better named as 2H-azole. 2H-azole, since 1, 2. So second position actually having an extra hydrogen. So 2H-azole, and this is like pyrrolidine. 2H-azole and pyrrolidine. So 2-pyrroline, that is C, will be the right answer. C will be the right answer here. Okay, pyrroline also known as under the name like dihydropyroles, and these are some different heterocyclic organic compounds containing differ in the positions of double bond. So it's basically used for the cases when there are not completely unsaturation and no complete saturations, like they are partially unsaturated rings. Next question we have, find the odd one among the following. Which will be the odd one among the following? So alicyclic compounds, okay, heterocyclic compounds, branch chain compounds, aromatic compounds. Okay, odd one among out. All right. So look, this is a cyclic structure. This is cyclic. Aromatic, the first condition for the aromatic compounds is that the compound must be a cyclic structure. So yes, this is also a cyclic structure. But the branched chain compounds, these like branched chain, they are chain compounds. They are not going to be cyclic. So yes, this is odd one among the given options. So yes, C will be our right answer. C will be our right answer. We have to find out the odd one. So this was the branched chain, so it can't be a cyclic structure. So yes, that was our correct answer. So this is all about today's video. So we are having 30 questions discussed from the topic organic chemistry, like basic nomenclatures of heterocyclic chemistry. So you have to practice all the questions, and you simply try to apply more these concepts on some further questions to practice more, and we will be meeting you again with some new topics, with some new questions. Thank you all.